Let's look at some radical expressions. A radical expression is a number underneath a root bar. That number underneath a root bar is called a radicand. Two radicals are considered like radicals if they have the same root and same within them, like radical x, but not radical x squared. You're not allowed to have a radical in a denominator, so we're going to do what's called rationalizing a denominator, which where we multiply the numerator and the denominator by that radical term, such as n over radical d will multiply by the fraction radical d over radical d to get a new fraction n radical d over radical d. This works to eliminate the radical in the denominator because the square root of d times the square root of d is the square root of d squared, or simply d. Let's look at some examples, like the square root of 18. 18 is the same thing as 2 times 9, so that's radical 2 times 9. And 9 is the same as 3 times 3, so this is radical 2 times 3 times 3. I can pair those 3's and take them out, giving me 3 on the outside of the radical, but 2 is left inside the radical. So my answer will become 3 radical 2. For radical 5 over 9, that's the same as radical 5 over radical 9. Now the square root of 9 is 3, so I can simplify that square root of 9 as simply a 3, leaving me radical 5 over 3. When we need to add radicals, it's important that they are like radicals. Here I see both numbers have a radical 7x. This means I have a 3 plus 8 times the radical 7x, which is going to give me an 11 radical 7x's. When multiplying radicals, such as radical 3 times radical 6, 3 times 6 is 18. So we need to be reminded of our factor trees here. That radical 18 has factors where it is 2 times 9. So radical 18 is the same as radical 2 times 9. And 9 has factors of 3 times 3. So we wind up with radical 2 times 3 times 3. Since this is a square root, I can take out that pair of 3's to the outside of the radical, leaving me with 2 on the inside, so 2 radical 3. Another way to do this would be to factor it from its multiplication, so that radical 3 times radical 6, but radical 6 is radical 2 times radical 3. Radical 3 times radical 3 is radical 9, which would give me 3. These are what we get from the multiplication properties of exponents. So I can pair those and bring them out to get my 3 radical 2, just as before. Remember that the exponent simply tells us how many times that parentheses term appears. Our multiplication properties with the exponents mean that I wind up with a 5 squared times radical 3 squared. And 5 squared is 25. Looking at 2 radical 8x times radical 4x, I want to break that radical 8x into radical 4 times radical 2 times radical x. I'm now going to break the radical 4x down into a radical 4 times a radical x. This is going to give me a 2 times radical 4 times radical 4 times radical 2 times radical x times radical x. A radical 4 times radical 4 is radical 16, and the square root of 16 is 4, and radical x times radical x is radical x squared, and the square root of x squared is x. So I can get 2 times 2 times x times radical 2. And when I combine my like terms, my 2 times 2 gives me 4, so I get 4x radical 2. In our last example, we're going to multiply a parentheses term by a parentheses term using the distributive property. So 4 times 3 is 12, and 4 times radical 5 is a negative 4 radical 5. Now radical 5 times 3, that's going to be a 3 radical 5. I like to use stacking and stack similar things underneath as frequently as I can, although occasionally I make mistakes. And radical 5 times radical 5 is 5, but that's a positive times a negative, so my term is going to be a negative 5. Now I add these all together to see the like terms, and I see that I get 12 minus 5 is 7, and 4 radical 5 plus 3 radical 5 is just a radical 5. My answer being 7 minus radical 5. Nothing easy is worth having, so math is highly desirable.